Get going. Looks like there's not so many people here today. I'm guessing it's either because A, they know they can watch it on the video, or B, they were up kind of late last night trying to submit the homework. Oh, there's an internship fair too. You know what? I mean, honestly, that's one of the reasons I like to have the video there, is if in case somebody wants to go to the internship fair or whatever, they can watch the video later, right? What's cool about it, like for people who do come to lectures, you get to ask the questions in a slightly less crowded venue, I suppose. But anyway, OK, so here's what we're going to do today, Wednesday, February 12th. I hope you all don't hate me after the homework assignment. I guess that's part of being a teacher, is giving hard homework assignments or homework assignments that take a while. But I will comment on the homework assignments. We'll do a few things today. Unix tip of the day, then the homework. We'll talk about the homework. Then we're going to talk about these things called the big three, which has to do with kind of the big three things that you need to know about if you're going to do somewhat extensive programming in C++. Namely, it's the destructor, which we've already kind of talked about. It's this weird thing called the copy constructor, and it's even weirder thing, to me anyway, called the operator equals overload. Okay, and we'll talk about what those mean and why they're important in C++ and why they actually haven't been necessary for you guys to write on your own quite yet. And then we'll go into these things called queues, which are kind of the next step after stacks, and in some ways similar, but have some very specific peculiarities that we need to discuss. Okay, let's quickly do the Unix tip of the day, which I wanted to show you. So I spent I don't know how many hours yesterday in the labs with you guys, and it was not in a bad way, but it was somewhat frustrating watching you type / ordered dynamic, right, every single time, like you wanted to rerun this thing. Let me show you something a little easier, right? If there's this thing called tab completion, you might have already, I mean, many of you have already used it before, but let's see what files I have in here. If I want to, so I've got a bunch of files in my folder here. If I want to do less on the TA office hours, right? If I just if I type less and then T and then the tab button, right? It will actually, it kind of flashes once or gives me a little beep once. And then if I do it the second time, what it does is it tells me all the different things that if I that start with T in my folder. So far, so good. And I go, oh yeah, it's TA uppercase office, right? And then same thing, and there it goes. Look, I hit tab again, and it filled all that in for me. I didn't actually have to type it, right? And then TXT, and then I'm done. So if you've got something in your folder, you can just type something like / and then O. Hit the tab button, and it'll tell you what's coming up. And in fact, if that's the only thing that starts with O, it will fill the whole thing in for you. And then you hit return, and you segfault, right? So no, hopefully not. That's what happened a lot of times when I saw people doing that yesterday. So anyway, so that's tab completion, and it works on it works in most shells these days. I think it works in the shells that are on your desktop when you log in. And it's just nice to be able to do that. OK, the other one, obviously you guys know about I'm hitting the up arrow key and the down arrow key. That goes to the previous commands, right? So if you don't have to like retype make again, you do the up arrow key until the last time you hit make and then hit return. And same thing for the actual program running, which is kind of cool. OK, the other one that not that many people seem to know about is this cool type of finding the commands you've done recently. If you hit Control-R, which I'm going to do now, Control-R, it will tell you reverse I search. And I'm not sure what that actually stands for. Incremental, reverse incremental search. Thanks, Bruce. And what that means is you can start typing letters in previous commands. So about 10 or 15 commands ago, I typed a grep command, right? And if I type G, oh, look at that. It does the exact same thing that I typed before, right? And so if that happened to be what I was looking for, it would actually, I would just hit return, and boom, it would go. So it actually does that. And if you keep hitting G, right, well, there's not actually any other G's in there in the one. But you can go back and do this. So ls was the last one that I typed somewhere along the line. I probably typed a period somewhere. Yeah. So You see what I mean? You can just you can do that reverse search, and it will actually find the previous commands you did, and you don't need to retype them. So it's kind of cool. Okay? So there's things like that that will make your terminal life a little bit easier, okay, going forward, if you remember how to do it. But Control R is the big one that, like I said, not that many people seem to know how to use it. Questions on those? I didn't think so. All right. OK, homework number 2. So provide. So there was a lot of chatter on Piazza last night and yesterday about, hey, provide's giving me these, like it's failing on these tests. I don't know what the tests mean, and so forth. 2 things about that. Number 1, well, at this point, hopefully you guys saw the post that said that actually printed out what the correct solutions were. Sometimes that'll happen in the code. Sometimes it'll just point you to a link. I gave you those links. A lot of people, we got a number of things saying, hey, are you sure that the provide script is working right? Because a whole bunch of us are getting like the same error on the same test, and that means that you must be wrong and we're all right, right? What you don't understand is how smart Bruce is and how well Bruce writes these things, right? So some of them do have bugs. That's true. And if you find, if you find them, certainly put something on Piazza and say, hey, is this one correct? And then Bruce will look at it and then he'll fix it, right? So, but as far as doing the tests, so the tests that we gave you in the main.cpp, right? There's a simple test which did it's inserted lunch or breakfast, then dinner, then lunch, I think, and that was it, right? That was kind of to say, hey, is your basic basic structure working to the extent that you can insert, and it will do it in order for a very simple test case. OK, that was easy. Then there was the advanced one. I probably shouldn't have called it. I should have called it like the semi-advanced one, right? Because all it did was take, I don't know if you looked through main at all, but all it did was it took the same 3 events, breakfast, lunch, and dinner, and just inserted them in every order possible into the list, and then it deleted lunch. And that was all it did. And that checks that you can do inserting before, inserting after, and all that. The sorts of things I didn't check for, right? If you had a linked or a dynamic array and you're inserting more than 5 events, right? Well, it didn't check that. Well, what happens if your expand method or expand code doesn't work? Well, that's going to fail, but we didn't test for that in the advanced test. Those are the kind of tests you need to actually write little test cases for. And it's going to take some time to learn how to do these sorts of test cases. One of them that I think a number of people actually they failed, that was one of the tests from provide, was inserting, it was deleting from the last item in a list. That's a little like corner case, we call it. It's a case where sometimes it's a case where you have to do something special, right? Inserting at the beginning, right? For a linked list, that's especially important because you need to make sure that the head points in the right direction or points to that new node that you just put in. You have to change that. So those kind of corner cases we didn't really specifically check for. You guys have to start writing some tests of your own that will check for that, okay? Most of the time, it's probably not going to be the provide script problem, right? Now, I do understand that all of a sudden it's 11 p.m. on the day it's due, and you get this, you do provide, and you get all these error messages. In the future, I'll do a better job of trying to make sure that we have provide up a little earlier. But again, provide is not going to necessarily, well, it should not be your first line of defense. Your own test should be your first line of defense. OK? All right. Have I lectured you enough on that? I hope so. Remember the corner cases. Now, I saw a lot of frustrated faces yesterday, right? I understand that. I've been programming for I don't even want to admit how long, like close to 30 years now, right? And debugging still takes a long time. I mean, I hopefully have gotten a lot better over the years, but debugging is hard, and I get that. And that's one of the reasons I say don't wait until the day before to start your assignment, right? You should be trying to do it ahead of time. That's the first thing about debugging. Look, just the bottom line, it's hard. Second thing about debugging is you need to do a couple things. You need to first step back a second, especially on those linked list ones, which are probably the hardest thing to debug, right? The linked list thing is just really hard to debug because there's these corner cases and it's not laid out in memory, quite as easily to think about. step back a second and say, what am I trying to do? Like, what's the actual algorithm I'm trying to do? And a lot of you were able to explain that, like when I sat down with you and talked it through. And a lot of times you'd say, oh, I get what's going on. I see where this mistake, it's got to be in this part of the function because we're trying to do it here and so forth. So that's the biggest thing. Step back and like re-figure out what your algorithm is. Then the other key is you have to go through line by line and say, OK, does this do what I want for the test case that I'm actually trying? You know, a lot of times it was, oh yeah, I forgot to do break right here. And some of you guys didn't understand, you know, what that actually entailed and why that was true. But so that's kind of a learning moment. But like you go through and you go, oh, it gets past this line and then goes to the next one when it's not supposed to, and that's what's screwing everything up. So, you know, the step by step going through is really important. And I know your eyes can bleed after a while of doing that, right? Take frequent breaks, you know, stretch a little, right? All that. And don't try to do it at 11 p.m. the night it's due. You'll go crazy. Programming in a pinch is difficult for everybody, right? I mean, it's one of the reasons that tech job interviews are kind of tough, right? Because they expect you to do programming right there. And if you forget, like, you know, the corner cases and things, that's where they're going to hammer you on. So it's difficult, but it's also, you know, a skill that you can gain over time. OK. And then I found out a lot of tough students get sick a lot because I got a whole bunch of emails saying, can I have an extension because I'm sick or I was sick? And so don't come anywhere near me, please. If you have been sick, as I said on the first day of class, I understand A, people get sick, B, people have 40 different things to do. Email me on a case-by-case basis. If you have some reasonable reason why you're not going to be able to finish an assignment, then we'll get you that extension, okay? For what it's worth. Don't stress over, you know, that part of it. But do please email me. Don't do. There's two things you could do that I would hope you would not do. A, it gets to midnight and you're like, I've just got to provide anything. It doesn't even compile. Go, right? And then go home and go to sleep. I mean, that's not a bad idea in that what's the point of staying up another 4 hours to try to bang your head against something? But I'd rather you email me and say, I couldn't get this to work. Can I talk to you tomorrow or whatever? And you know, when I talk to you, I'll say, when did you start the assignment? And if you say Tuesday morning, then you know, I'll know you're truthful. And B, I'll maybe chastise you a little. But the point is, you know, I don't want you to just provide code that doesn't work because you're frustrated and you're done with it, right? I'd rather you talk to me about it. But again, the other thing I don't want you to do is, if you have some mitigating circumstance, like being sick or whatever, just kind of, you know, go through it and don't think that I'll understand that, because I will. OK. Anything else on the homework? Any comments about either the dynamic array? You probably don't even want to think about it at this point. But any comments on the dynamic array or the linked list? Yeah.
Were there cases where we suggested to use assert?
I don't think we put in anywhere where you needed to use assert. There were some cases where you probably could have checked, you know, you could have done that. In this case, it was a pretty generic, I mean, if you tried to cancel an event that didn't exist, I would rather you just return than say assert doesn't exist, right? I'd rather, you know, and I think that's what one of the things we check for is canceling an event that doesn't exist in the list, right? That could be a possibility of asserting, but in this case, just return, just you know, say, well, it's not there, I don't need to do anything. You know, so that sort of thing. So I can't think of any off the top of my head in particular where you'd need to worry about that. Yeah. Yeah, question.
Just because we provided the make file along with everything else, I found that it was kind of difficult to change it to make to test other aspects of the function. I had to copy it all into another file.
Oh, I see. Because you provided the make file, we are not going to worry about. I don't believe our script ever uses their make file, does it? Bruce, do you know? I don't think ours does. Yeah, I mean, here's what I would suggest in the future: making just a copy of the original make file, and then changing as much as you want, and then at the end, you know, copying back the original. That's probably the easiest way to do it. But I hear you. I mean, it's, you know, it does make some changes. You can rely on the make file to do some of your tests if you'd like. Like if you want to do it, you know, you can make it do that. I hopefully built this one so that you could test one or the other. I mean, I remember doing that, so that was a little. But if there were specific cases, yeah, you got to change the file. It's not the biggest deal, I hope. Yeah, good. Any other comments or questions on that homework? Yes, Sarah.
Make a small comment for everyone.
Yeah.
Yesterday when I was in the office hours and people were going crazy doing their work and it wasn't working, when it comes to linked lists, people have to draw at least a list of the items to know where the arrows are going. Because everyone screwed up the arrows because they started like imagining in their head their linked list is going like that, and when they do it on paper, they think, now I know what's wrong.
Sarah, that's a great point. So for those of you who didn't hear, Sarah said, look, draw out your linked lists in a picture and make sure you have at least 3 links or 3 different nodes in the picture, because then you'll be able to look at a bunch of different cases, right? I mean, there's a special case when there's no nodes. There's kind of a special case when there's 1 node sometimes, depending on how you wrote it. And so having at least 2 or 3 nodes in there where you're going to have to point things in the direction that, make 2 nodes point in different directions, that's an important part. So thanks, Sarah. Yeah. All right. Anything else? And I'll stop bugging you about it. Yes?
I know there was a lot of clips about LPS, but just like to clarify, when we provided and we got the error about converting into that I just was curious.
Yeah, I apologize about that. The good question. So the question is, when we got that, some of you got an error that said there was a conversion problem between an integer and a long. Turns out that when you multiply in some versions of the compiler, and Bruce, correct me if I'm wrong on this, but when you multiply by just a number like 2 or whatever, sometimes it actually does a conversion where it converts everything to a different type of integer, like a long instead of a regular int. And some compilers will flag that. The newest version that we're using in class and in homework doesn't flag that, which is why you wouldn't have seen it. And then I believe we used the other compiler to do it. We'll try to do in the future have the same compiler do it. So I think that's the thing. But no, you do not have to worry about that. No points will take it off. And again, I mentioned this a couple times on Piazza. If we make a mistake, we're not going to penalize you. I mean, it's not. We're trying to be fair here, right? I mean, we're not going to penalize you if our thing has a mistake. I mean, it might make it a little harder for you to debug something if you're seeing this error and say, oh my gosh, there's an error and it is our problem. So I apologize about that, but we're not going to take points off. And if you do get your grade back and you think something's wrong with it, just email and we'll fix it. OK. Anything else? All right. Let's go on to the big 3 that I mentioned a little bit earlier. OK. So here's what they are. We've all heard of a destructor before. OK. We'll talk about what that does. There's this weird thing called a copy constructor, and then this other one called an operator equals overload. OK. You know how? Well, we'll get to that one. We'll start with the destructor first. The destructor is just the part that it cleans up your resources. And if you are using new, especially in your private variables that you're using, if you're doing new in a constructor, you will almost certainly have to do the delete on that same item that you are gaining as new somewhere along the line, and generally in your destructor. We also do it in other places too, like if we have a list that we're expanding, we delete the list right there. Once we've expanded the old one, we delete the new one because the destructor only deletes the last one. But the whole point of the destructor is clean up after yourselves. Okay? A lot of people, I've heard arguments before about, well, if I'm just running one class and it's going to run, and when the program ends, it's going to clean up anyway. Not a very good way of thinking, in that somebody else could use your class and then have a million different copies. And if your class doesn't clean up after itself, there's a memory leak. And that's the big thing about the destructor. Anyway, destructors in general, there is one created for you. By the way, all 3 of these things are created for you, but sometimes don't work the way you think they are, which is why you have to think, oh, am I doing something where I need to create my own? OK? All right. The copy constructor is an interesting one. If you have a class, like if you have a class A, OK, and you are going to, let's say it's a class A, and you do something like this, A, right? That will give you lowercase a, an instance of class uppercase A. OK? If you do, you can also do the following, right? You can say A, let's say lowercase b, some other instance of the class A, And what this will do is it will basically say, OK, create a new instance of the class and make it equal to the one that we've already got. So if you have some class A and it's got a whole bunch of variables and things, and you set them all, when you do this, you're saying, now give me another instance of A called lowercase b that is the same as the instance we already have. And so there's some copying that's going on there, right? It's got to somehow copy the data from A into B. And it can do that in most cases pretty easily. Copying data is just a matter of going through the variables and copying them if the variables aren't, let's say, a pointer, which we'll get to. I mean, it can copy the pointer, but we'll talk about the issue with that in a second. OK. And I will show you examples of all this too. The operator equals is another interesting one. If I have two integers, right, int a equals 5 and int b, like that, OK, I can say b equals a, like that, right? And now, hopefully, b will be 5 after this statement. So far, so good? That equals sign works, well, in C++, is able to work for more than just regular old types like integers or floating point values or whatever. It will work for classes. So let's say you had A, and you had a class, uppercase A, like this one, right? And then you made a little variable like that, lowercase a, which is a type of the class. And then you did another one like that. Somewhere down in your code, you want to say, oh, well, now b has got to equal a. You can actually type b equals a, and hopefully the same sort of thing will happen. It's very similar to the copy constructor, except that this already exists. OK, b already exists. You've already created it somewhere else, and it exists. And you have to copy it over, copy the stuff from a into b, and that will do it, right? OK, so that's what's going on with the operator overload. Now, why do we call it operator overload? Because that equals sign, in general, only knows about types like ints and floats and regular types. When we write it, we can write a special type of function that says, no, 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 I don't want equal to be what, exactly, because just for in regular types. I want it to apply to my class. When I type b equals a, I want everything to copy over properly. And again, sometimes it doesn't work the way you think it does unless you write it properly. And I'll show you what I mean. OK? Any questions on the big ideas so far about these three things? The first one is about cleaning up. The second two are about copying data across. Yes? Why would you do this? Why would you ever say b equals a? Do you ever do anything like that in your code? Well, only for normal variables. Well, OK, let's see an example. Well, I'll show you an example in a little bit. I'll show you an example using the day class that we're doing, right? That we had for the calendar. OK, if you have day, a day, right? A day. Right? And then somewhere later, you want to create a new day, but you want it to copy that one because you're looking through it and you want to change some things. Let's say you want to reorder it just to print out in a certain format. Like somebody says, hey, give me it in a reverse order or something, and you want to reverse it in there. Something like that. You might do that. You might say, new day. Well, you'd say something like day, new day equals a day, or something like that. So sometimes you want to do that where you get a copy of your class, right? And when you're passing around classes, remember classes they allow you to do a whole bunch of things like carry versions of the class around and copy between the two and so forth. Okay, so there are lots of times you will want to do that for your classes.
So if you made a copy, then you could change the copy with the.
Yeah, that's exactly right. Yeah. That's a very good point. So Rose is saying, look, if you make a copy, then you can change that copy and it won't affect the original, right? And that's kind of the whole point of this, is that we'll show you where that doesn't necessarily work when you want it to work that way. Yeah? Yeah, as it turns out, for this case right here, This one is actually the copy constructor, I believe. The details of when it happens, don't worry so much about that, except to know that the copy constructor works when you're creating a new class, instance of your class. The operator equals works when you have two versions and you just want to copy one into the other. So you've already got some other B that you've already created, right? That's when the equals ones works. We're going to go through this relatively slowly, and you'll see what happens when we do this. Other questions on it? OK. All right. So I'm going to throw some code at you, but we'll go through it relatively straightforward, and I've tried to highlight where necessary. Let's say I have this is a pretty silly class, right? It is a class that just holds an integer. Okay? It's got one private variable. It is an integer. I've made it a pointer. Okay? I've made it a pointer because I wanted to. Right? I didn't really need to in this case, but let's say it could have been a list or it could have been something else. But to make it a relatively simple example, we'll use this stored value. Okay. And we have a constructor, right, that says if you have some initial value, you're going to input some initial value in the constructor. You're going to pass an initial value, and it could be 0. And if you don't pass one, it is 0 automatically. And what it does is it says stored value equals new int of that value. So what the constructor is doing is saying, OK, I've got a pointer here. Give me some space to put an integer, and then point that integer at that space. That makes sense? And in fact, put the actual value there into that space. OK? So let me draw what it's going. So the stored value starts out like this. Stored value, OK, it's a pointer. It points off to nowhere. We have no idea where it's pointing before the class actually gets started. When you do the constructor with, like, let's say 7, right, you will say something like int cell, is it int cell? Yeah, int cell a equal, or a 7, right? And that actually puts a 7 into the value. So it creates some box. It says new int value, or int, gets some box, it puts a 7 in it, and then it points your stored value down to there. That's all that's happening in that line, or in the constructor. OK, so far so good? All right. You've got some getters and setters, standard stuff. I've written them like this only to fit on the screen. Sorry. OK, normally I would do them properly. And I should do commenting too, but up here for the screen we do it. OK, that's all that does. Let's see what's going to happen here when we do this. OK, and I'll show you what we're doing. All right. So we are saying int cell a2. OK, so a is now going to be 2. OK. And then, and this again, because of the room, I'm writing the next line over here. That should be on the next line, but C++ doesn't care. My own obfuscated C, I guess. In this case, it's saying int cell b a, which, as we said before, in a copy constructor, you get a copy constructor built for you. It doesn't actually come, I mean, you don't see it, but it gets built for you. And what this is saying is b is going to get the contents of a, right? That's what the copy constructor should do anyway, right? So when we do this, what we're hoping is that b will equal 2, because b is whatever a is, or b becomes whatever a is because it gets constructed, it gets copied in there. Okay? And then we create another cell c, which is going to be another one, which is just going to be c, and it's not going to have any value yet, right? We don't even know what the value is yet. Okay, everybody with me so far? All right. Now we're going to say c equals b. You believe we would want to do that sometimes? All right. So we're going to say c equals b. So what should c say? What should c be now? We're going to hope it's going to be 2. Okay? And then we're going to say a set value 4. And a is going to go, OK, it's going to set value 4, and it's going to go where a is pointing, and it's going to make it 4. So then a should be 4. OK? And I think I actually have, I probably should have, oops, hang on. There, yeah, there we go. I've been using the pointer when I could have just used this. OK. And then it's going to print everything out. All right, so it's going to print A, then it's going to do a new line, then it's going to print B, a new line, print C. Okay? This is what it actually prints out. Maybe not. There we go. It prints out 4, 4, 4 instead of 4, 2, 2. Okay? Can we figure out why that's the case? Sure we can. Right? We can look at it and we can go, hey, let's draw our little picture of what actually happened here. Okay? Let's go back a little and just see exactly what happened when we did this. When we did int cell A of 2 there, okay, what happens? It goes to the constructor and it says our stored value is a new integer there. So we're going to create a new integer. We're going to point stored value there. And it's going to be, in this case, 2. Okay? All right. Then we say int cell B of A. All right. The copy constructor, all the default copy constructor does is it says B is going to get whatever A's variables are directly. Okay? So right now, this is A dot stored value. Okay? When we do this, it's going to say B dot stored value points to there. Okay? That's what that one does. And then this one we create a C that doesn't point anywhere. The stored value doesn't point anywhere. In fact, the C itself doesn't. And then when we say C equals B, the equals operator is going to say, OK, make C stored value also point to there. Right? There's only one copy of that actual data right now. Then when we go and we set A value to, or we set value for A to 4, well, guess what? We're shot. Right? That's the issue. Because now, because it's a point, because these are all pointers here, they're all pointing to the same piece of memory. When we change that one piece of memory, that's what we do. This is probably not what we wanted to happen. Now, it could have been, but it's probably not what we wanted to happen. When we changed A here, we also changed B and C. You would rather that doesn't happen. It's not a particularly good way of thinking through designing code, right? Well, what do we have to do? Yeah, question.
I guess what's confusing me is the initial value gets 0. So like when you call C,
Yeah.
why is it pointing to nothing, and why shouldn't it be, like it should be pointing to 0?
You know what? You're absolutely right. Yep, you're absolutely right. C is pointing to 0. When you do this line right here, you're right. It calls the constructor and it points it to 0. It does make the value point to 0. So yeah, you're right. Is that all that's confusing you? Good. Yes?
So if the store value is not a pointer, then that will not happen.
Yeah, if this wasn't a pointer, first of all, you wouldn't have done new, because you can't do new on something that's not a pointer in this case, right? It's already the value, the data is there for you. Then it would pass along the actual value and have space in each instance of each instance A, B, and C. It would have extra space for an integer, and then it would do the copying correctly. So that wouldn't happen. Yeah, good question. Okay, all right. So let's see how we can fix this. Okay, all right. Now I have to. Lots more code, but it's the fixes are only because we actually have to draw this. Okay, it's basically the same stuff except for the new constructors that we're doing and the new operator overload. Okay, same thing, right? We don't have any except for it's now called fixed. We have now same thing. Nothing's changed there. This next line here is where we have our copy constructor. Okay. We have barely touched on what things like const mean and some of these other like little things in here, and like we did touch on a reference. When you do your copy constructor, it has to have the const in there, and it has to be a reference. Otherwise, it will fail. But here's what this means. Okay, here's what we're doing. We are saying it is another constructor. Notice it doesn't have any return type. It's another constructor, and it's saying, give me a reference to another int cell fixed class. Okay, which is exactly what we're doing when we do this right here. Doesn't that look exactly like that? You got B parentheses A, which is exactly some B parentheses for your one parameter. So far, so good? OK. Then what it's saying is, I know this is a pointer, right? Because I made it a pointer. I'm going to create a new a place to point to. And then I'm going to copy the actual value from the right-hand side stored value into my stored value. Now you've got the two pieces of data, and you can go and change one and not affect the other one. Okay? And that's all you have to do for this. Copy constructor is not magic. It's just you have to remember to do these things. Okay? That's what the copy constructor, how that one works. And by the way, some people will say, hey, how can this is some other variable. How do I touch its value? Why can't I do the getter on it? Well, it's because it happens to be the same class. And that's part of the reason you can touch other private variables for other classes that are the same class of you, for other instances of the same class. Question? Yeah.
When you both the constructor, copy constructor, and the other constructor,
Yep.
whenever you call C,
Uh-huh.
you don't pass any parameters into the function.
When you do C, right? That calls the default constructor. Whenever you do it this way, it happens to call the default constructor, which is this one. It calls it with no. See this part right here? It says int initial value equals 0. That actually tells us when you do it like this, set that value equal to 0. That's what it's telling you. So yeah, it's a C++. It's part of C++. I apologize again for C++ being the way it is, but that's what it does. Good, very good question though. Yes.
But then right now, C is not pointing to the same thing that A and B are pointing to, right?
Well, yes, correct. Yeah, when you do this, it isn't. We haven't gotten there yet, but when you do that, C is pointing off to its own little copy of a variable that happens to be 0. That's what it's pointing to. Yeah, good. All right, everybody got that part of it. If you don't, that's all right. You can go back and look. I haven't posted the notes yet. I will post them a little later. OK. The operator equals 1. This is saying, for this class, int fixed cell fixed, redefine what equals means. It's called overloading it. It means redefine what equals means. Okay? And this happens to be the syntax for it. You literally say operator and then the equals sign. And you have to make it a reference as well. And this is just that's the form. That's what they do the way they do it in C++. OK. And then the same thing. You're going to pass in a reference to some other already constructed class instance. Okay? The next line here is a little odd. Okay? The next line here says what? It says if this is not equal to the right-hand side, and this means me, the one that I'm trying to create right now. Right? The reason we do that is because it's basically saying, hey, if I'm trying to do something like A equals A, just return. Don't worry about it. Now, your point is well taken, whereas why would you ever want to do A equals A, right? Now, sometimes you write a loop, and you're going through a loop, and it happens to have the other variables in the other loop too, and you end up doing something similar to that when you're saying some variable equals itself. Hopefully the compiler might find those instances and take them out or whatever. But sometimes you'll do that. You want to check for that because sometimes, and this is not a good case of that, but sometimes, and I'll show you one later that is, you actually need to delete the old version of something, let's say, and do it. In fact, Bruce, I'm incorrect in this one. I should have deleted the old one, shouldn't I have? Yeah, I believe I should have. This is the old stored value. I should delete it first. Yeah, I actually forgot to do that on here. Because in the equals constructor, C is already created. It's already got a new, I'm leaking memory here, in other words, because I forgot one thing. I'll change it for the thing. What should happen here is stored value already exists for C. It's already pointing to some variable that's been declared as we're using new. And now I should delete it first. So that's a mistake on my part. But that's why this is important. You don't want to delete something that already exists that you're going to try to copy from it again, because it would not work. Let me just change it right here, since I have the time. Let me just change it right here. This is what, and Bruce, correct me if I am wrong on this, but I believe this is what I want to be doing. Oops. Hang on. Where'd it go? right here, what I want to do is delete stored value. Like, no, then you can't dereference it. No, right. You do. Well, you don't want to dereference it. For stored value. All right, maybe you're right. Okay, I'll have to look. But a lot of times, many times you will do a delete here, which is one of the problems. Are you sure? Yeah, I guess you're. Well, you're right. You're right. You have to in this case. I'm thinking of the next case. Which is where you have to actually have to delete it because because it's like an array. Well, yes. So I will go look at it again and then explain it if I'm wrong on the next one. Okay. So anyway, but the whole point of this is what it's doing is it is saying, hey, the stored value is now equal to the right-hand side stored value, very similar to this one. In fact, exactly the same as this one, so that it puts the value into there, into where so it actually does the copy correctly instead of just copying the pointer. Okay. Questions on that one? Yes.
Are there any operators that would
You can overload a lot of different operators. I would tend to avoid doing that because it does. I think it's a little confusing. But when you get a little more advanced into C++, you certainly can. There are some other operators. One of the big ones that gets overloaded a lot is the double less than sign, right? Which is the C out that uses that. That gets overloaded for various types because how do things know how to print themselves? Well, you have to actually overload the double less than sign so that it is able to call the right part of the function to print itself. So yeah. Yeah, it would still work. So it's built in for you. Like the compiler says, oh, you didn't build one? I'll build one for you. But all it does is it copies the actual, it would say the pointer value here points, it would say stored value equals right-hand side dot stored value. In other words, it would point directly to the same box that it pointed to before. So it wouldn't create it wouldn't use its own box, in other words. That's what it would do automatically for you. Good question. Anything else? Another hand up here? Okay, I know this stuff is confusing. You'll have to look at, and I mean, look, I'm getting confused with it, right? But it's kind of confusing. All right. Which? Oh, sorry, yes. Good question. The meaning of this. The meaning of this, that's a big question. In this case, this says the object that I am starting with. So it's the one that I'm trying. Down here, where do I do this? Right here. C equals B, right? When I refer to this, it means C. So if I say, if this equals right-hand side, or is not equal to right-hand side, if I said C equals C, then this would be the same as that, using this and that. But anyway, point is that it refers to the one that you are actually acting on at the moment, not the one that you've passed in. That's what this means. Yeah. OK, other questions on that? Yes? The previous slide.
Yeah, and for the second in cell B, the argument is A, but the type of A is a pointer?
The type of A is an int cell.
Yeah, so but for the constructor, the argument should be an integer?
No, because it's not. So C++ knows if you are calling a function to create a new, if you're calling a constructor to create a new function. So it knows to differentiate between this one and this one, or this one and the copy constructor. Yeah, very good question. Doing it this way calls that one that was built for you. The compiler knows that that's what it is. It's another part of C++ I don't love, but it knows that for you. Good question. Very good question. Yes?
So does that mean that if you have more
Uh-huh.
it will still know to copy the.
Yeah, the default one will copy any of your private or public variables. It will do that for you. It just goes, oh, there it is. I'll copy it for you. Boom, 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 boom. Right? It copies. In fact, it also copies all your functions and everything. Okay, it copies it all for you. But the problem is when you get to the pointers, it doesn't know to go down inside. What we're actually doing is this thing called a deep copy. Okay? What it means is the compiler will very gladly copy all your variables themselves, right? A pointer happens to be just an integer. It's a big integer, right? But it's an integer, and it points to something. That's all it is. The compiler will very happily copy that for you. It doesn't know how to copy your specific type of data if you don't tell it how to, which is what we're doing in the actual copy constructor. Yes?
What happens if you want both versions of the operator equals? So like if you want them use a temporary pointer, and you want it to point to the
Oh,
right,
good question.
you also have this form in the same function.
Yeah, I don't think you can overload it and have your cake and eat it too, in other words. I think you'd need to figure out, you'd need to say, yeah, choose one. You want to err on the one that most people are going to use, which is hopefully the new one. I mean, that's kind of because that's generally the way we describe our functions is if you set something equal, it's not going to be equal to the thing that it's pointing to. Although if you ever program in Python, Python does do exactly that for some cases, and it's not very fun when you don't realize that and try to figure it out after midnight. Yes?
So if you go back to the previous slide.
Yeah, back to the previous slide.
I could be wrong, but I thought the reason why a class has private
Yep.
values is because it wants to protect it from anyone just doing anything they want.
Yes.
But doesn't this give access to
In the next slide, you mean?
No, this one.
Which one?
In cell D with A.
Oh, yeah, it kind of does. I mean, in some sense, it does give access to that. Now, when you pass pointers around, you are by default giving access to somebody to whatever that points to. I mean, you can't change. B can't say, I want to change A's stored value. But once B has a copy of that pointer, it can say, oh, now I want to change my pointer, which happens to point to the same thing. Therefore, it changes A. So, yeah, kind of. I mean, it really does. Yeah. In pointer, and this is why a lot of times in C++ we try to get away from using pointers because that's exactly right. Yeah, you give it. Unfortunately, a lot of times it's not possible to do that. I mean, you have to have a situation where you give somebody the access to what it's pointing to. Otherwise, it'll run too slow, or you just won't be able to do what you want to do. But yeah, that's a very good point. Very good point, Richard. Yeah. Yeah.
You just said the pointer, the type of a pointer is kind of an integer.
Yes.
So if there are some other values in the private parts of the class itself, can you still pass the A as an argument?
Yes, you can. The default constructor will take any of your variables and copy them directly over. So it will do all of them for you. If we had another one here and we were writing our own copy, we have to take care of that. We have to do that copying for you. So you have to if you go ahead and say, look, I know what I'm doing. I want to write my own copy constructor. You have to take care of it all. That's your job at that point. The compiler says, OK, it's yours. You handle it. But you're right. It will do all the other ones. Good question. All right. Anything else? I know there's a lot to get your head around. But that's OK. Let's see. We were here. We were then here. I didn't change any of this. Right? This was all the same as before. We're going to do the exact same stuff as before. And now, ta-da! Remember how before? OK, so we say A is 2, which is what we wanted. B gets A, so it originally points to 2, right? And then, well, it points to it has its own value that is 2. C has a value of 0, we said. C now gets a copy of B, so it's got its own value of 2. And then now we set A's value to 4, and B and C don't have anything to do with that because they've got their own copies and they know nothing about it. They're pointing in the right direction to their own copies, and we're good to go. When we print out, we get 4, 2, 2. And it doesn't actually print yay, but I thought it was important. Yeah?
What's the reason for the cost?
Yeah, good question. I should have figured someone would ask that. a lot of times when you pass data from one thing to the other that you don't want to change, that you don't want the function that's using that data to change, you'll declare it as const, which says, I'm not going to let you change, the compiler's not going to let you change it. So if we had somehow in here, if we had, let's see, in here said right-hand side dot stored value equals 3, it would have complained and it wouldn't have let us compile it. So it's really a check for the programmer. In fact, you have to use const for the copy constructor and the operator. That's because of the way they're designed, they force you to do that. Your own functions, when you get to a point where you know you're not going to change data, you can do that. Our textbook has like pages and pages and pages about const. And it really is overwhelming, like to try to like figure it all out. I mean, over time as C++ programmers, you will figure this stuff out, but it does take a little bit of time. Okay? All right. Good questions. I'm glad we're going through this somewhat slowly. You'll, when I mention copy constructors later, we'll kind of recall this and go, oh yeah, you'll go, oh, I get why we're trying to do this. Okay? All right. Let me show you how the day class, which you're probably sick of looking at, although you didn't look much at the .h file, I'm guessing. The day class has a whole bunch of public stuff, and then it has three different very private variables in it. Okay? If I try to do this, day equals new day, and then I did a copy and I set it equal to this, do we have a problem? Right? We do. We have a problem because, okay, we are not doing that deep copy with the default constructor and the default copy constructor, or the default, in this case it's the copy constructor that gets called here. We aren't doing that copy because it's exactly the same thing as we just went through in great detail. Okay? So you didn't have to do this for your homework too, because we never did. We never passed days around. We had one day. We never copied it. We didn't need to worry about it. Events, as it turns out, events did not have these in there. If you go look, events had 2 integers and a string. And a string counts, even though it's a class, they built the constructor properly, so it actually works. Okay? So you can pass those things around. You can't do it for a day. So as we make the program a little bit more advanced, we may have to start thinking about writing these for our day. Okay? And I don't want to go through all the deals here because of the time, but it's exactly the same thing. We're now creating a this is the copy constructor, and it has to do the actual copying of all the data that's in that list, right? It has to go and copy all of each event, copy, 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 copy. Because it's a list, and if we didn't do this, it would copy the pointer to that list. Now you've got 2 lists. You change one event in one list, and it changes the other one in the other event, which is in the other list, which is probably not what you want. Okay, it's not what you want to do. So that's why we have to write this be a little more explicit about this. Okay? All right. Let's look at the equals overload one. Same thing. I'm checking to see if I accidentally, or if I said, did I want to say a day equals a day? Here's why we want to do that. Okay? In this case, we want to say, we change the event count and event capacity. We make them the same as the one we're passing in to copy. Then we have to delete the event list for the one we've already got, because in this case, we already have some day that's already got its own event list. That's when we have to say, hey, delete it. Okay? Bruce, am I right on that one? Hope I'm right on that one. I did this at like 5 this morning. But anyway, I think I'm right with this one. But the point is that we are taking the one that already exists and deleting it. It's exactly like the expand function. What's that? Woohoo! Here I did it right. OK. I wrote the other one at 4:30, so that was the problem. No, not quite. It wasn't that early. It wasn't that early. All right. So anyway, and then in this case, then we make a new event list that's as long as the old one we want to do. It's very similar to the way we copied things before. And then we copy all the events, and we're done. And then this time, the equals always returns a pointer to itself, as it turns out. That's the way equals always works. And so you can chain them along, as it turns out. You can chain equals. You can say like A equals B equals C. So it chains it along. Okay? Questions on that? Again, I'll put this code online. You can go browse it as you want. OK, that's enough of the like super crazy C++ stuff, and that's enough for now, for a while, I hope. Let's get back into the fun stuff, which is some other data structure. OK. Anybody here from a Commonwealth country? Where are you from? Barbados, yep. Canada. Yeah, I guess Canada counts, doesn't it? Yeah, you guys, you have the Queen, don't you? Yes. In Commonwealth countries, you generally, when you go to a supermarket and you stand in line, what's that called? It's called a queue, right? It's also called a queue in like American English too, but people rarely use it, right? You go, I'm going to go stand in line. In Barbados, you'd probably say, I'm going to go stand in the queue, right? OK. Now, most of you hopefully heard that anyway. But that's what we're going to talk about next. OK, we're going to talk about queues and how they and why we need them and what they actually are in terms of a data structure. OK. We're kind of building up here. We went from lists to stacks, and now we're going to talk about queues. Queues are just a little bit more advanced than stacks. Not much, though. Just a little bit more advanced than stacks. They are just lists, again. Okay? And instead of following the first in, last out, or last in, first out, like a stack, they follow a first in, first out. Okay? If you go to the supermarket and the line was set up that the last guy in line was the first one to get served, right? That would be really bad. The guy who got there first would be kind of upset if anybody comes after him, right? You'd be kind of annoyed at that. So we have these ideas called queues, which are you insert at one end and you delete at the other end. Okay? So for instance, okay, if you have a queue here like this, we're going to say that it's going to look it might look a little bit backwards, right? We're going to say that we're going to put something here and then put a like variable or some object in here, and then the line is going to back up that way. Okay? So this is now going backwards C, and who gets taken care of first? This guy. And then this guy gets taken care of, and then this guy gets taken care of. Okay? That's the order that it's going to happen in. Okay? You put them in like this, right? You put them in this way, and then you take them off from the other end. Okay? So it's just like a queue if you're lining up at the supermarket, right? A comes into line first, and then B, and then C, and then A gets taken care of first, right? It's a first come, first served sort of idea. Okay? Queues have two different methods that we're going to worry about right now anyway, and they are pretty simple. Much like push and pop, they actually allow you to put something onto a queue and to take it off a queue. When we put something onto a queue, we say it's in-queued. All right? And we insert at the end of the list. Okay? And we dequeue, we delete from the beginning of the list. Okay? That's how a queue actually works. Okay? You in-queue at the end, and you dequeue at the beginning. And just think of it just like any other line. You don't go and go in line at the beginning. You'll get yelled at. I accidentally tried that once I accidentally did it once at the Empire State Building. I don't know if you've ever been to the Empire State Building. Like, you go up there and you stand in these lines that like wrap all the way around this one like level and just wrap around. And I was there with a friend, and we walk up, and I'm like, oh, I guess we go over here. And we like walked right to the front of the line. And then it was somebody yelled at us, and some New Yorker yelled at us, and whatever. Although why New Yorkers? I don't know. Don't see that many New Yorkers in the Empire State Building, surprisingly. Like at the top, anyway. They see it all the time. OK, anyway, so that's how the list actually works. OK, you in-queue at the end, and you dequeue at the beginning. OK. Just like stacks, this is a very fast operation. Both the in-queuing and dequeuing is very fast. Okay? If you have a dynamic array, you actually don't need to move things, because you're always pushing into one end and taking off from the other end. You don't actually have to move objects around. Okay, we'll talk about, you might think, oh, if I take A out, I'll have to move B and C back. Turns out you don't have to. I'll show you that in a minute. But it's very fast, so you don't have to do that. We actually call this, we'll get into what this means later, order one, meaning it happens in like one operation. Okay? You don't need to go walking through any lists or moving things around. Okay? For a linked list, if you're going to do this, you better keep a head pointer and a tail pointer. Otherwise, this gets blown out of the water. It's not efficient. Then you have to walk all the way down the list to add something. Right? And we don't need to move the array. I'll talk about what that means in a second. OK. All right. Let me do this. Before I go into that, there's kind of an advanced example. Somebody gave me a very good tip the other day and said, let's try to work on simpler examples than we've been jumping into these big, long examples. Although this one's not too bad here. OK? Well, this is actually, is it the next one that we want? No, we'll get to that in a sec. The array keeps 2 positions. It tells, just like any other line in general, it knows where the front is, and it knows where the back is. OK? There are various ways to implement this, but let's stick with this model for right now. OK? There's a front and back, and it also tells you how many objects are in that list. In this case, 4. 1, 2, 3, 4. OK? It points to the front, points to the back. Pay no attention to the fact that it's actually no space down here, or there's nothing down there yet. OK? Here's how you enqueue something. OK? To enqueue some element, well, we'll do 1 in this case. Increment well, yeah, I guess do I have it X? Hang on. No, let's make it 8. Here, I'll change this. Again, do stuff too early in the morning. 8. I thought I'd changed it, but maybe not. 8. OK. All right. So if we want to enqueue element 8, increment current size and back, because we're going to have one more item, and increment back, and then set the array back equals to 8. OK? That's how we're going to do it. I guess I could have left it as X, but yeah, here we go. Same thing. To enqueue element, increment current size and back, then set the element back to 8. I did change it, I guess. All right. So now instead of 4, we've got 5. We've moved back to the back of the array. Any questions on how you enqueue, or what's going on, or why we're doing this? OK. To dequeue an element, you set the return value to the front, whatever's at the front. You make current size 1 less, and then you increment front. So if front starts here, right, what you're going to do is you are going to return 5 and move front to here, because now this is the front of the line, the front of the queue, right? No, this isn't rocket science. In fact, this I think is a very straightforward thing that we're doing here, right? It goes from the fronts now here to here. Don't bother deleting that. Don't bother moving anything. We'll see why in a second. OK? All right. This is what I wanted to say before we get into this. Let's just try inserting 1, 2, 3, 4, 1, 2, 3, 4, 5. OK. Here's our queue, right? And let's start out by trying to kind of walk our way through inserting some things. Let's insert like A through D or A through E into this. And we'll enqueue A through E, and we'll dequeue somewhere along the line. And we'll try to track what's going on here. OK? It's a special case when you've got an empty list like this. There's ways you don't necessarily need to make it a special case. But look, for now, let's pretend it's a special case. OK? When you insert when you enqueue A, so you're going to enqueue A. OK? And let's say I'll put it like this. You're going to enqueue, EQ. We're going to enqueue A. OK? And the current size after that's done is going to be 1. And we're going to put it right there. So far, so good? OK. Where's the front of the line, the front of the queue? A. So front is going to point there. Where's the back of the line? A as well. So back is going to also point there. OK? All right. Now we're going to enqueue. Let's enqueue B. So we're going to enqueue A. Then we're going to enqueue B. OK? We're going to increment back. Increment back. And put B right there, and make sure we make our size 2. So far, so good? All right. Let's do the same thing for C. Enqueue C. Same thing. It's going to increment back, and then we're going to put C in there. So back is going to be here, and C is going to be there, and we're going to be 3. All right. Let's dequeue. We don't know what we're going to DQ yet, but we're just going to DQ, not Dairy Queen, DQ, Q-U-E, right? And we're going to DQ, and we're going to do what? We're going to return the value A, so we're going to get A out of here, okay? And we're going to make front point to the new front. And we're going to make sure our size is now 2. Question?
Do you have to actually delete A though?
Oh, you're right. I don't even delete A. I even said that before, didn't I? You just leave A. Absolutely. Question?
I get why you would want to know the size, just like in general, if you're actually using this, but do you need it to actually implement the queue? Like what can you...
What do you mean do you need it to implement a queue? This right now is just a list, for instance. This is an array.
You could theoretically keep track of the queue with just the front and the back.
Oh, you mean instead of size?
Yeah, like you don't actually need to keep track of the size. Like I get why you want to use it, but is there any reason if you're just
Well, let's do this. Let's DQ. Let's DQ 2 more times. Okay, DQ and then DQ. Okay, what's going to happen? Front is going to move to here first. We're going to get B out of it. I won't delete it. Then we're going to DQ again, and it's going to be 1. Then we're going to DQ again, and front is now going to move here. And we're going to get C out of it. And what if I tried to DQ again? Right? If I DQ'd again, I would have some sort of assertion failure, or there's nothing to DQ here. There's no front anymore, right? I mean, there is a front, but there's nothing to DQ. The list is empty. So that's one reason to keep the current size around. Now, I know some of you guys, yeah, go ahead.
You don't need to deal with back when you do that.
Yeah, you don't actually need to do it back. Somebody clever in here, it might have been you who brought the question, could have said, look, in this case, if the list is empty, back is always 1 less than the front, right? Because look, back is here and front is here, and if I check that, I do it. You have to be really careful with that. There are some corner cases, and there are some other issues that you have to deal with when you do that that make it so that it's a little trickier. Okay, but yeah, I mean, you probably could figure out where it is, but you just want to make sure that keeping this makes it easier on you in the end. Yeah, good question. Yes. Yeah, in this case, they are pointers. Yeah, I mean, depending on how you implement it, they're pointing. But yeah, front points to this part of the array, back points to this part of the array. Yeah, yeah. You can do it in different ways, but you can just keep them as counters and just make sure the counters are lined up. Okay, but yeah, very good. Other questions on it? Yes.
So when you DQ, do you want to delete?
No, actually, and that's a very good point. You don't want to delete. For a number of reasons. Deleting is slow, as we found out before. In fact, some of your code last night took a long time to do that flood event thing. Bruce put that in there especially to laugh at you guys. No, I'm just kidding. He put that in there so that to test to see how long your code, in fact, we're going to do tests a little bit later on how long your program takes to actually do those thousands and thousands of events. And we'll report to that on you. So it's, it makes a difference. So if you can get away with not deleting, you don't have to. Okay, and we'll see what we can do in a second. Yes?
Is it a dynamic array?
This one, yeah, good question. Let's pretend this one right now is not a dynamic array. Right? If it's not, what's the problem? And that leads right into the next little issue, right? What's the problem? Well, the fronts here, let's say we in-queue a couple more things. Let's say we in-queue D and in-queue E, right? And our size is now 2. And so that means that back actually ends up here. All right, now what? If we try to in-queue again, we'll run out of space, right? You could make a dynamic array out of this, but you certainly could, right? You could just, oh, we got the back here, let's make more space, right? But are these being used anymore? No, they're not even being used anymore. So let's reuse that space if we can. That's the kind of the key. Somebody had a question over here? Anybody else? No? OK, so we're going to try to reuse that space if we can. You can do it where, let's say you're full and you try to in-queue. Well then, yeah, you're going to have to increase the space if you want it to work properly. But if it's not, we can do a cool other technique, okay, which is up here. Okay, so the problem is when you get to the end here, you get to the last one here with the in-queuing, you run out of space. But we've been dequeuing along, so we've got all this extra space here. Right? Let's do this. Okay? After 10 enqueues, it's full. Okay? Queues in general, and you hope, unless you're like calling AT&T or something, queues get smaller, right? As you call like the phone company, it seems like your queue you never actually get to the front of the queue, right? Queues generally stay relatively small because you're in-queuing things, and the whole point of a queue is to be able to dequeue things as well. So if you're pushing things in and taking them off, this whole overall size of the queue stays pretty small. Okay? So in this case, look at this. I mean, how many events or how many objects are in here? There's only 2 right here, right? There's this one and this one, and that's it. So we've got all that extra space. Here's what we can do. Whenever the front or back gets to the end, wrap around to the beginning. Right? It's called a circular queue. And that's all that's going to happen. So I've got like 4 minutes. I can walk you through this. Maybe we'll start again if I'll try not to go too fast here. But let's see what happens here. Let's say we start in this situation right here. Okay? We start right here, and the back of the queue is here, and the front of the queue is here. Okay? And what I'm going to do is I'm going to move the bottom one up to the top, and then put a new one in there. I tried to get the animation to work, but it wouldn't work. So in other words, step 1 is on there now, and now this is still step 1, and this is step 2. I don't want to confuse you guys with like, this is what we just did, and this is what's coming up next. Okay, so this was the initial state. And then after we in-queue the number 1, well, we move back up 1. Oops, it hit the end, wrap around to the front. Right? And then put the value there. Okay? And our current size now is 3. 1, 2, 3. Okay, everybody get what happened there? It's a little tricky, but it makes it nice when you're dealing with queues. Same thing. This is step 2. Now this is step 3, the one we're doing right now. After you in queue 3, same thing. You move back over 1. Now it's easy. You don't hit an end. And you move it over and you do 3. Okay. All right. 3 is there. After you dequeue, all right, what did we do? We dequeued. We took 2 and we gave it back to you, returns 2, and we moved front over to here. All right. So that's what we did here. After we dequeue again, we move front. We return 4, and we move front over to here. Aha. Okay. Yes?
Is this why you said you had to be careful with defining an empty queue when that is behind front?
Yeah, that's one of the reasons. Yeah, good question. When you're defining or when you're finding how much or what, if it's empty or not, you have to do this. This is modular math. I mean, it's like base math, right? Where you're wrapping around, and you need to consider those. So the math gets a little bit tricky. Not hard, but tricky. Yeah, good question. Yes? Nope, you build them yourself. I mean, you have to take this into consideration. When we build queues, we build circular queues, we're going to have to take that logic into consideration. Okay? All right. So then we say, OK, so then we've dequeued 4, or we've dequeued, and then we dequeue again. Front was here. We dequeue. We get 1 back. And now the front and the back point to the same place. OK. Let's try one more. Dequeue again. So front, or we take the last value out, and we move front over here. And it doesn't have any value to point to because there is the stack is or the queue is empty. And that's that. Okay. So I think, yeah, there's a couple more slides in here, but the whole point is that's all you have to do for these circular ones. Question here and then back there. Yeah. No, go ahead.
If you didn't queue again after this, would the back still be pointing to 3?
If you in queue.
Yes.
All right. If you in queue after this, what do? You move back to here, and you put the value there.
But would the back be pointing to 3 then?
No, back ends up pointing here.
It does? Okay.
Sure. We can have the back and the front be the same one. If there's one value in the queue, back and the front better point to the same value. Because it is the front and the back. We are a queue of 1. Right? Yes?
How can a queue be empty if there's something at the back?
How can a queue be empty? These values we've already taken care of, and we're just ignoring them.
But if the back is pointing at 3, then there's something in the queue.
Yes, there is something. Oh, no. Did we, let's see, after DQ. No, it turns out that it's not because it was pointing back here, and we know that there's 0 in the queue. You've got to be careful with that. You have to know if you have 0 in the queue.
Oh, so the back
Okay.
can respond to something and then it's the
Sure.
empty queue.
Yeah, it can, but you got to know where you are, that you have 0 items in the queue. Yeah, yeah,
There's something at the back of the queue.
yeah, yeah, yeah. Okay, good. See you guys later.